Hey guys, in this video we're going to talk about M.1.8 and M.1.9. So the first thing we're going to talk about is the ratio. A ratio is a comparison of values. It's basically a fraction. So I want to illustrate, with this first example, how we can use a ratio to describe this picture right here. Now, let's look at number 1 first. It says, what is the ratio of oranges to apples? So I'm going to show you 3 different ways we can write this. The first way is, since we're comparing oranges first, that's going to come first in our in writing our ratio. So we count the number of oranges that we have. We have 1, 2, 3, 4, 5, 6. So that number goes first. We're comparing oranges, which is 6 oranges, and then we put a colon. We're comparing oranges to, and then apples is the second number. So apples, count them, 1, 2, 3 apples in this picture. So this is one way to write our ratio. We can also write it as a fraction. We can say, since we're saying oranges to apples, the word before 2 goes on top. Which is oranges, and there's 6 oranges, so that comes on top. And then the 2 is like the fraction bar, and then apples, we have 3 of those, so that goes like that. So that's another way to write the same thing. These 2 things mean the same thing. We could also write 6 to 3. Right? These 3 things boxed are the same way of writing the ratio of oranges to apples. Now, if we look at number 2, if we want to write the ratio of apples to oranges, well, apples comes first, so we just switch the numbers here. So like apples, we have 3 apples, colon, 6 oranges. Apples to oranges. And same thing with the fraction. Apples, 3 comes on top for apples, 6 goes on bottom, and then we can write it 3 to 6. And before I move on to number 3, I want to mention that, since ratios are fractions, we can reduce them. And typically you're going to be asked to reduce these ratios fully. So how do we reduce 6 over 3? Well, to get an equivalent fraction, we divide top and bottom by 3 to fully reduce it. And what we end up getting, let me write this over here, 6 over 3, if I reduce by 3, is equivalently 6 divided by 3 is 2, and 3 divided by 3 is 1, so that's 2 over 1. So this is our fully reduced ratio. Whereas here, if I fully reduce 3 over 6, divide top and bottom by 3, 3 divided by 3 is 1 on top, 6 divided by 3 is 2 on bottom. And what does that mean in the picture? Taking a look at number 1, we're looking at how many oranges per apple, okay? So, and we can group them in that way. It says for every 2 oranges, there's 1 apple. But also it says for every 6 oranges, there's 3 apples. That's pretty clear. But the second equivalent fraction says for every 2 oranges, there's 1 apple. And you see we can group it like this to see what that means. For every 2 oranges, there's 1 apple. So just a different way of grouping things. That's what equivalent ratios allow us to do here. And the second statement says for every 3 apples to 6 oranges, that just means for every 1 apple, there are 2 oranges. And we can see that this is illustrated in this picture as well. For every 1 apple, there's 2 oranges. Okay, so that's that. So let's look at number 3. What is the ratio of apples to fruit? All right, so I'm just going to write this as a fraction. So we have apples on top, fruit on bottom, apples to fruit. So count how many apples there are. There are 1, 2, 3 apples. Count how many fruit there is. So, we're counting all of the fruit. So 1, 2, 3, 4, 5, 6, 7, 8, 9 pieces of fruit in total. Apples and oranges. And then we can reduce this completely. So if I reduce by 3 to get an equivalent ratio or fraction, if you like that, 3 divided by 3 is 1, and 9 divided by 3 is 3. So the ratio of apples to fruit is 1 to 3. So for every 1 apple, there are 3 fruit. Alright, so that's what that means. So that's the basis, the idea of ratios. So we can also think about ratios in a geometric sense. In high school, you probably talked about similar figures quite a bit. And the idea is that similar figures are the same shape, but different sizes. So what that means, the same shape, is that the ratio between their sides are the same. So let me show you what I mean by that. Now, if you look at this figure right here, this small triangle, we have a base of 1, and we have a height of 2. So if I compare base to height, what I get is 1 to 2. Alright? So that's for this figure right here. Now, in the bigger triangle, we have a base of 3 and height of 6. So if we do our comparison here, we get 3 colon 6. And we can reduce 3 over 6, right? 3 goes into itself once, 3 goes into 6 twice, and so we can see that, these are secretly the same ratio. So that's one way to see it. The ratio between the sides are the same, but we can just see that, this guy is a scaled up version of this guy, right? And what this is saying is, if I take all of the sides of this small triangle and I multiply all of those sides by 3, the result is this big triangle. You see that? So 2 times 3 gives us 6. 1 times 3 gives us 3. It's scaled up by a factor of 3. That's what we call that. So similar figures have the same ratios between their sides. And you can see, how this shape right here is very different from this shape, right? I mean, they look to be the same size but the ratio between the sides is clearly not the same, right? All right, so if we take a look at this little guy right here, he has a ratio of 1 to 8. We're comparing base to height, okay? And then this guy over here has a base of 2 and a height of 16. Now 1 over 8 can't be reduced, but 2 over 16 sure can be, right? 2 over 16 is the same thing if we divide top and bottom by 2. 2 divided by 2 is 1, and 16 divided by 2 is 8, right? So it reduces to that. And what this is saying is that this guy is a scalar multiple of this guy. So this guy is a scalar multiple of this guy. And it's scaled up. This little guy is scaled up by a factor of 8. Okay, so the ratio between the sides are the same. That's what creates the same shape, even though they're different sizes. Okay, let's do some more examples. Lisa has 7 sci-fi books, 3 romance books, and 8 fantasy books. First question, what's the ratio of sci-fi to romance books? Well, sci-fi comes first, so I'll put that on top. And you can use the colons too, it doesn't matter. But I'm going to use the fraction here. So sci-fi is 7, 2, romance is 3. There's 7 sci-fi books for every 3 romance books. Okay. And that can't be simplified. What about fantasy to romance? So there's 8 fantasy books. 2, how many romance books? Well, there's 3 romance books. 8 to 3. This can't be reduced. Ratio of romance books to total books. Well, the total books we have 7 sci-fi, plus 3 romance, plus 8 fantasy. And that's going to be 18 total books. So romance, there's still 3 romance books. So this is going to be 3, 2 total, which is 18. And we can reduce this guy, right? 3 and 18 have a common divisor. They can both be divided by 3. So if I divide top and bottom by 3, this is going to give me 1 to 6. So for every 1 romance book, there are 6 books in total. Okay, so a proportion is a ratio in fraction form set equal to another ratio in fraction form. It's basically an equation with 2 fractions. So let's go ahead and do an example and see how we can evaluate or solve proportions, rather. Okay, so the legend on a map reads 1 centimeter equals 20 miles. You measure 6.4 centimeters between destinations on a map. How far in miles are the destinations? So we need to set up 2 fractions, one on the left side of the equal sign and one on the right side. And we want to make sure that our units are at the same level. So the 2 units here, we have centimeters and we have miles. And so if I put centimeters on top right here, I need to make sure centimeters stays in the numerator over there as well. So, and you don't have to do it that way. You could put miles on top, centimeters on bottom, it doesn't matter. But I'm choosing to put centimeters on top and miles on bottom in both cases. And this is just to show you where to put the numbers, okay? So the first statement says that 1 centimeter equals 20 miles. So for every 1 centimeter, we have 1 centimeter to 20 miles, okay? 1 centimeter to 20 miles. And you measure 6.4 centimeters between destinations on a map. So that's where this guy goes. And we're wondering, 6.4 centimeters on a map is equivalent to how many miles? Okay, so question mark by the miles. There's a couple different ways you can solve proportions. I'm just going to show you how to do it algebraically since, just to stay consistent with what we talked about when we were solving equations. Now, I'm going to just write this without the units because the units were just to guide me where the numbers go. So I'm going to just write this without the units. Okay. And I'm going to go ahead and simplify. Well, what could I do? I want to get the question mark. I want to see what that is. So the first thing I'm going to do is I'm going to multiply both sides by 20 to get rid of that denominator right there. And you could do it in a different order. It doesn't matter. So on the left, when we do that, we just get 1. On the right, 6.4 times 20 over 1. Well, it's just 6.4 times 20. That's going to give us 128. And we still are over the question mark. Okay, so it's like your x. Like we're trying to solve the equation for x. And did you have to multiply both sides by 20 first? No, you could have taken a different approach, but if you do the algebra right, like if you don't violate any of the rules of balancing equations, then you're going to get the right answer. At this point, what I can do to get the question mark out of the denominators, I can multiply both sides by the question mark. It's just like multiplying both sides by x. If you want to call it x, call it x. I don't care. When I do that, that clears, and question mark times 1, anything times 1 is itself. So I get that my answer is 128. So, and it's asking how many miles is 6.4 centimeters equivalent to? Well, we just found out with our proportion that's equivalent to 128 miles. Pretty cool. Alright, let's do another example. Micah spends 27 hours in a 3-week period practicing piano. At this rate, how many hours will he practice in 7 weeks? So pause the video, see if you can set up your proportions, or your proportion. We have bar equals bar. Now what are our units? We have hours and weeks. So it doesn't matter what you put on top. I'm going to put hours on top. But we have to make sure if we put it on top on the left side of the equal sign, we have to put it on top on the right side as well. So hours to hours over week. Okay. Now it says, it gives us our first ratio. It says 27 hours to 3 weeks. Okay. He practices for 27 hours in 3 weeks. So 27 hours to 3 weeks. And we're looking for how many hours, so that's where the question mark is going. And it says, how many hours is he going to practice in 7 weeks? So the question mark is going to go above 7. All right, now we can get rid of the units just to make it a little bit cleaner so we can solve this algebra problem. Now, what I see on the left side is that I know what 27 divided by 3 is, right? I know that that simplifies to 9 before I start even moving anything around. So 27 divided by 3 is 9, so I'll put that there. And now I just have 9 equals something divided by 7. Well, how do I undo division by 7? I need to multiply both sides by 7. And I get my answer. I get question mark is equal to 7 times 9 is 63. So my answer is 63 hours. He's going to practice for 63 hours in 7 weeks. Okay, the success rate of a salesperson is 2 out of 11 calls. At this rate, how many sales would a salesperson expect to get? So how many sales out of 55 calls? So our units, we have sales and we have calls. So I'm going to set up my proportion. I'm going to say on top, I'll put how many sales that the salesperson gets, and on bottom, calls. Equals sales over calls. Notice that calls are level with each other and sales are level with each other on top. So the first ratio that we have is 2 out of 11. So for every 11 calls, we get 2 sales, 2 successful sales. And then how many sales? So that's where the question mark goes with sales. How many sales would a salesperson expect to get with 55 calls? So the 55 is going to go on bottom. Now I'm going to get rid of the units and just put 2 over 11 equals question over 55. And right away, since the question mark is on top on the right side, I can just knock this out in one swift movement by multiplying both sides by 55 to get rid of that division by 55. Now the question mark is isolated, and 55 times 2 divided by 11 is going to give us 10. So, should expect to get 10 sales for 55 calls. There are 3,400 students and 200 teachers at a high school. If an additional 250 students are added to the school, how many new teachers need to be added to keep the ratio the same? So the first ratio that we start off, we have 3,400 students to 200 teachers. That's what we know right off the bat. And what we need to figure out is what we're looking for on the right side. So since we put students on top on the left, we'll put it on top on the right, and teachers on bottom. Okay, so the second sentence says, if an additional 250 students are added to the school. So we have to take the students that we had and add 250 to say, okay, well, this is going to give us the new amount of students, which is 3,650. And our question is, how many teachers does this amount to? Okay, so let's go ahead and solve this. And I'm going to first start by getting rid of the units, just because they're kind of in the way. So we have 3,400 divided by 200 equals 3,650 divided by question mark. Now, on the left side, I can see that 3,400 divided by 200 is 17. So I'm going to just right off the bat change that to 17. Now what I can do, since I'm trying to figure out what the question mark is, I can undo division on the right side by multiplying both sides by the question mark to clear the denominator. So I have question mark times 17 is equal to 3650, and finally I'll divide both sides by 17. So 3650 divided by 17 is 214.7. However, we can't have 7/10 of a teacher, so we're going to round this up to 215. Now, this is, the answer right here, but it doesn't answer the original question. It says that the ratios are now the same, right? 3,400 students to 200 teachers is exactly the same as 3,650 students to 215 teachers. But the question asked, how many new teachers need to be added to keep the ratio the same? Well, we originally had 200 teachers, and then we went to 215 to keep the ratio the same. So the answer here, from 200 to 215, we added 15, and that would be our final answer. Okay, the next section we're going to talk about is M.1.9, solving real-world problems involving ratios and rates of change. So ratios with units are just called rates. So for example, we could have 2 cats per 3 dogs. Cats and dogs are the units. So, and this guy tells us it's a ratio. So ratio with units is a rate. 7 absent to 10 present. Absent and present are the units. 6 miles to 2 hours. Miles and hours are the units. So these are all examples of rates, just ratios with units. Now, a special type of rate that we talk about a lot in math, and that you probably use a lot in your own real-world experience, is the unit rate. And the unit rate is just a rate that has a denominator of 1 unit. And so, for example, if we have examples of unit rates, we could have miles per 1 hour, miles per hour, or I don't know, dogs per 1 cat, and so forth. So the denominator has to have 1 unit in the denominator. That's a unit rate. So it's pretty easy to find the unit rate. We just divide the numerator by the denominator. And the unit rate is also called the rate of change. So unit rates are important financially, right? Like, you can make some decisions about what to buy at the grocery, for example. Those big stores that sell things in bulk, like Sam's and Costco, people go to those stores because the unit rate is cheaper. So, you have a big giant jar of peanut butter, and I don't know why I keep thinking about peanut butter, but peanut butter's been on my mind lately. And you have this big giant jar of peanut butter at Sam's, and it's like $20, and you're like, oh my gosh, who would pay $20 for a jar of peanut butter? But it's huge, and you calculate the amount of peanut butter per cent or whatever, or cents per ounce of peanut butter. And it's a much better deal than if you were to get the peanut butter at Walmart. So anyway, that's why unit rates are important. Let's do some examples. Lucy works at a bakery. She pulls out a recipe and discovers that the number of cups is unreadable for a cake recipe. Her boss tells her that yesterday the bakers used a total of 22 cups of cake flour to bake 6 cakes. How much flour does she need for a single cake? Okay, so we're looking for flour. We're looking for a unit rate because this girl only wants to bake 1 cake. And she's like, well, I know that it takes 22 cups of flour to bake 6 cakes, but how much does it take to bake 1 cake? So we can set up a proportion here. We can say, well, 22 cups is to 6 cakes as, and maybe we'll just say cup flour, just to make it clear. So cups of flour. So 22 cups of flour is to 6 cakes as how much cups of flour is to 1 cake. Once we find out what this question mark is, we'll have this as our unit rate. All right. So how do we find it? Well, it's pretty easy. So if I do 22 divided by 6 equals question over 1, well, question over 1 is just question on the right. And so our answer is 22 divided by 6, which is going to give us about 3.7 rounded. So that's our answer. So 3.7 cups of flour per 1 cake. So our unit rate is 3.7 cups of flour per, ran out of room, but the 1 cake should be on the bottom. Per 1 cake, that's our unit rate there. Let's try another one. So, all right, now you have this is where unit rates are interesting to people when they're trying to figure out a better deal, right? So we have 2 vacation deals. Option 1, we can pay $900 for 4 nights. That's a steal, I think. Well, I guess it depends on how many people you have. If you have a big family like me, it's a good deal, but maybe not for 2 people. Anyway, here's the deal. $900 for 4 nights or $1,443 for 7 nights. What is the better deal? And so to answer that question, we want to know how much are we paying per night? That's going to give us our answer. Okay? So, for the first one, we have $900 per 4 nights. And we want to know how many dollars for 1 night. Okay? So how do we do it? Well, just set up the proportion. 900 over 4 is equal to question over 1. Question over 1 is just question. 900 divided by 4 is 225. So for deal 1, we're going to be paying $225 per 1 night. Okay. For deal 2, it says we're going to pay $1,443 for 7 nights. You know, you can just divide the numerator by the denominator. That works too if you don't want to do this whole process, but just for the sake of continuity, I'm going to do it like this. But yeah, just divide numerator by denominator if that makes you feel better. If you like that way better. Okay, so this is going to be equal to how much money per night? And so we have 1443 over 7 equals question over 1. Question over 1 is just question. 1443 divided by 7. It's 206.14. So deal 2, I'm paying $206.14 per 1 night. So which one's better? Well, deal 2 is better because it's cheaper. And that is how we can use unit rates for that problem. Okay, peanut butter again. See? You see what I mean, guys? I keep thinking about peanut butter. Don't know why. But here we have a jar of peanut butter. And so this is when you'd be at Walmart or Sam's or Costco, and you would compare the cost per ounce. So a jar of peanut butter costs $12. Oops. I didn't mean to get rid of that. $12.62 for 20 ounces. How much does it cost per ounce? So our units, we have dollars per ounce. So this is our ratio. And we're looking for our unit ratio, so how much money per 1 ounce. Okay, let's go ahead and just transfer the numbers down since we have our units taken care of. We have $12.62 over 20 equals to question over 1. Question over 1 is just question. And so $12.62 divided by 20. Okay, so that's going to be 0.631, so that's approximately 63 cents per ounce. You can put the 1 ounce, or you can just say 63 cents per ounce. Same thing. Okay, a water cooler holds 5 gallons of water, which is enough to serve 40 athletes. There are 17 volleyball players, 25 soccer players, and 67 football players. How many gallons of water should you serve to each team? Alright, so the first sentence tells us our base ratio. We have 5 gallons to 40 athletes. So 5 gallons to 40 athletes. And so we kind of have to parse this up because each of the categories, each of the sports categories has a different number of players. So let's start with volleyball first. So it says there's 17 volleyball players. So I'm going to say, well, we're looking for how many gallons should I serve them? How many gallons should I serve 17 athletes? Specifically the volleyball players. Okay. So I'll go ahead and transfer my numbers down. We have 5 over 40 is equal to question over 17. What I can do from here is I can multiply the right side by 17 to get the question mark alone. So 17 over 1 times 5 over 40. Let's see what I get there. Okay, I get question mark equals 2.125. So for my volleyball players, I'm going to be serving them 2.125 gallons. And you do the same thing for the other categories. We have soccer and football. So for soccer, we have 25, so I'm just going to replace the 17 down here with a 25. And do the same kind of process. So 5 over 40 is equal to question over 25. Multiply both sides by 25 to clear that denominator. And I have 25 over 1 times 5 over 40. And I get 3.125. And this is for our soccer players. Okay, and finally football players, we're just going to change the 25 in the denominator to a 67 and solve like we usually do. So 5 over 40 is equal to something over 67. Multiply both sides by 67. 67 over 1 times 5 over 40. And we get 8.375. And this is for football. Okay. Let's see where we're at. Okay. A recipe for Dijon chicken that is designed to serve 6 calls for 3/4 of a tablespoon of brown sugar. How much brown sugar is needed to serve 22 guests? All right, so we can set up some proportion here. So the units, we have tablespoons, or, well, maybe we'll just call it brown sugar. We have brown sugar, tablespoons of brown sugar to people. Okay, so the first sentence tells us that 6 people, so there are 6 people to every 3/4 tablespoon of brown sugar. So 3/4 brown sugar to 6 people. So we're looking for how much, question mark, brown sugar for 22 people. All right, so let's go ahead and write this out. We have 3/4/6 is equal to something over 22. Now, I don't like this complex fraction on the left, so I'm going to go ahead and simplify that first. To simplify a complex fraction, we keep the top and multiply by the bottom flipped. Now, 6 flipped, 6 is technically 6/1. So 6/1 flipped is 1/6. So we keep the top multiplied by the bottom flipped. Okay, flip 6, you get 1/6. Okay, and then I can cross simplify. So 3 goes into itself once, 3 goes into 6 twice. Multiply straight across to get 1/8. Okay, so we have 1/8 equals something over 22. Now let's go ahead and figure out what that question mark is by multiplying both sides by 22. And I get 22/8, which is 2.75. So we are using 2.75 tablespoons of brown sugar for 22 guests.